Myself, Bipin Patil, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. In today's session, we are going to discuss small complex problem on a support reactions. These are the learning outcomes. Means at the end of this particular session, student will able to solve the complex problems on a support reactions. Let's we begin with the problem. Find the support reaction find the support reaction for given beam. So the beam is look like in this way. Here the roller support, now here UDL is there. This height is 1 meter, 1.5 meter. Now here at 1 meter, point load is there 100 kilonewton. Intensity of this particular UDL is 50 kilonewton per meter. The next one exactly at 1.5 meter, one couple is there. It's in a clockwise positive couple, 10 kilonewton per meter, and the remaining distance is 2 meter. Here the support is present, that is hinge support. Now our task is to identify the support reaction present at A and at B. So whenever you are calculating the support reactions, first you may show the normal reactions present at joint. So first of all, we are considering here first one, that is the at A. You may observe here one vertical reaction is there, and exactly at a B two more reactions are present. So one is here RA, and at B one is horizontal, that is HB, second one is vertical, that is VB. How we can calculate the support reaction? So apply moment at any one point. I am considering now point A. So at point A is equal to 0. So summation of moment at point A is equal to 0. Before that, the UDL is present here. So you may convert that UDL into point load. So the distance you may consider here, this distance they have given, that is 1.8 meter, and the angle is also they have given here. This is theta. So theta is 33.69 degrees there. Let's you observe, I am separating this particular portion. So UDL is present, point load acts like this. This distance is now 1.8. So divide by 2, 1.8 by 2, 1.8 by 2, 0.9 is there, 0.9, 0.9. Now this angle they have mentioned, that is theta. This is the midway. So the total is 0.5, here 0.75, 0.75 is there. Now 50 is there, 50 into this 1.2, it comes near about 90 kilonewton is there. Two components are present, one is horizontal, second one is vertical. So here this is the cos term, this is the sine term. So 90 cos the theta, and the theta is 33.69, and 90 sine 33.69 is there. So let's we calculate the moment. First one, the RA. So the moment at point A you may consider here. So RA into 0 is there. RA into 0. Next one, 100. It moves in a downward direction and it creates clockwise, so positive, plus 100 into the horizontal distance is 1. Next one, you may consider here couple, that is positive clockwise, so 10. Further VB is there and HB is there. HB the same line of action, so minus plus what it may be, it moves in a left hand side, so HB into 0. Further you may consider VB is present, so VB it moves in upward direction, moment center is present in a left hand side, so it creates negative, that is anti-clockwise rotary effect, so minus VB into this particular distance 2 plus 1.5 plus 1, so you may consider here it's 4.5, 1 2 3 4 5. Now two terms are present here, one is horizontal and vertical. So the horizontal term, that is 90 cos, it is present here, so 90 cos, you may write down first 90 cos 33.69. okay, it moves in this direction, and now we want from the movement center this particular distance. So here to here the vertical distance is present, that already we have calculated, it's 0.5. So 90 cos 33.69, and it creates clockwise rotary effect, so positive, and the distance is 0.5. Next one, sine term is present there, so like that for sine we are calculating continuation of this, plus or minus, so it moves in a downward direction and it creates clockwise, so positive sign, positive 90 sine 33.69, and the distance we want from here, okay, so from here to last end, so 1 plus 1.5 2.5 plus 2 4.5 plus 0.75 is comes 5.25 is there, equated to 0. Now you may do the calculation and calculate the value of VB. It comes 117.35 kilonewton is there. Similarly, you may apply the next one, that is all horizontal and all vertical forces equated to 0. So the same figure you may consider. So we are considering summation V is equal to 0 and summation H is equal to 0, these two terms. Summation V means RA upward positive, VB upward positive, 100 downward negative, or you may consider in a right hand side, and one more force is present, that is 50 sine, so plus 50, you may convert into UDL, so it comes 90 sine 33.69, it moves in a downward direction. So you know the value of VB already we have calculated, find out the value of RA. So put the value of VB, so VB it comes 117.35, so put the value of VB, find out the value of RA, so RA it comes 57.53 kilonewton is there. Similarly, you may calculate the value of horizontal forces, that is HB. How many horizontal forces are present here in the geometry? So you may observe only two horizontal forces are present. One is that is you may consider here the 90 cos, and second one is your HB is there. So HB moves in a left hand side, so minus HB. 90 it moves in a right hand side, so plus 90 cos 33.69. Okay, one force, second, that's all. Only two forces are present. So rearrange the terms. 90 cos 33.69 is equal to HB. So the value of HB is equal to 49.92 kilonewton. Now you have calculated the value of HB, value of VB. Now we want the value of RB. How we can calculate the value of RB? So RB is equal to, now you may consider the root, that is your all VB square plus HB square. So put the value of VB, put the value of HB, and you may calculate the value of RB here. Please do the calculation and identify. So the value of RB comes 127.52, that is your kilonewton is there. Similarly, you may calculate the position of that particular resultant. So tan inverse, we are considering your VB and HB. So like that, if I calculate it, this particular value, it comes 66.95 degrees there. So in this way, easily we can calculate this is your problem statement, and in this particular problem statement, first one the RA value, second one the VB, HB is there. So HB and VB, like that we are calculating the value of RB. So this is the moment first step. We have converted the UDL into point load. So we have calculated the value of VB. We have calculated here a value of RA by considering summation V. By considering the summation H, we have calculated the value of HB. Now by the conditions, easily we can calculate the value of RB and theta. So to prepare this video, I have referred, these are the references. Thank you.